All right, so for today, today you are solving trig equations. Part of the struggle here is we have to be good at circle trig first, and so I want to make sure to take at least one more problem of circle trig. So would you please start with this, which is an inverse trig question, which then should cause you to rewrite it, and it'll become a circle trig question. And then you'll have certain restrictions, like, oh yeah, inverse sine isn't allowed here or there. In fact, those are enumerated right here with the red and the blue. That reminds you where you can do inverse cosine and where you can do inverse sine and inverse tangent. So there's a lot on this page. Use all of that help. It's reminding you where you're allowed to do inverse sine. And solve this question. All right, so here's what I hope you did. I hope you did a rewrite. And the rewrite would look like this. This is sine of some angle has to equal -1/2. But it's almost like there should be an asterisk, because this would have had two answers. And we can't let it have two answers. So remember how inverse sine, it says right in this picture here, inverse sine is only allowed in that blue zone there. So that means these guys are out. Can't be here, can't be here. And sine is negative. See, there's a negative right there. That means it can't be here. So that it had to be here. Next, you had to remember sine is opposite of right hypotenuse. -1, 2. This is square root of 3. Next, you had to remember that the thing across from the -1 was a 30-degree angle. But that's not really 30. It's pi/6. And that's not even the right answer either. Why is the right answer not pi/6? Yes, Melissa. -pi/6, because it's going down from this to 0, -pi/6. And last hour, somebody was thinking it might have been 11 pi/6, which I get. Their thought that that might be 11 pi/6, but no. Why not? Do you remember that we're only going, the highest anything ever goes is pi. That's kind of a weird thought, but it's true. Because the answers that are down here, they never cross into the dead zone. And in here, they are only negative answers. So the answers that you end up in here sometimes, those answers are negative and they're small because they don't go all the way around, right? Okay, so in this whole unit, I've told you a few things that are just like gonna happen. When you do an inverse trig, you're only gonna get one answer. Number two, your answer never will be bigger than pi. Because see, pi is right there, and you're never going to go here, which is where it would be bigger than pi. And this would theoretically be bigger than pi, but you don't use numbers that are bigger than pi. You use negative numbers that are small. Okay, so your answer will never be bigger than pi. All right. So what is the answer after all that, Mr. Server? It was not pi/6. It was what? -pi/6. Okay. So that was yesterday. So what's today? Well, today is where you combine one of your favorite all-time units, the identities unit, with circle trig and inverse trig, all at the same time. It's going to be so much fun. All right, so right now I would like you to find the sheet. It's in Schoology, and I re-put it in there for you. So you can pull it up, and if I were you, I'd do the split screen dealy, Bob, because you're going to keep referring back to the sheet. And I'll ask you, like, what's cosine of 2 theta? And you'll be like, no idea. I'm going to go look on the sheet. Along those lines, cosine of 2 theta is a unique one because you have 3 choices. I will tell you, never pick the one that's got sine squared and cosine squared in it, because then you've got 2 functions to deal with. You'd rather only do one. A lot easier. So when you have cosine of 2 theta, you got 3 choices. Don't pick the one that has sine and cosine in it. It's not as fun. All right. So let's get the warm-up page. Well, the domain and range. The range is the one that really matters the most. So let's just focus on the range for now. That's that picture I just showed you, and I drew for you yesterday, where you've got like, where is inverse sine allowed? Where is inverse cosine allowed? Would you please write them out here, here, and here? What are the ranges of inverse sine, inverse cosine, and inverse tangent? All right. I know most of you are thinking this is sine and tangent, or both of those are in that spot, right? So then what's the answer? Well, remember we called this negative pi over 2. If you said 3 pi over 2, no, you can't say that. And this is pi over 2. Okay, so I would say for sine, it can touch, so I'm putting a bracket, negative pi over 2 to pi over 2. And inverse cosine, that is this area, and that's from 0 to pi, and it can touch it. And last but not least is tangent. It's a lot like this one, but it's different. It's negative pi over 2 to pi over 2, but in parentheses, because it can't touch it, because tangent has asymptotes there, so it isn't defined at pi over 2 and negative pi over 2. Okay, and we just did a practice problem like this. And I'd like you to try this one, and don't let it hurt your brain. How do you start all inverse trig questions? We've started every one the same way. Melissa, do you know? Good. And that would be sine of what? Nice. Now, from here, it all seems fine. And go and draw a picture, and then you'll be like, I hope. Wait a minute. What's the problem? Sure. Okay. What if I said there is a denominator, but it's a 1? So what's the problem? Yes?
That would work because you can't have hypotenuse is right. Sorry, you can't have that smaller than one of your sides.
Yeah. Another way to say it, the hypotenuse has to be the biggest side. And it's not. So what's the answer? Let me ask you this. Picture the graph of sine. We just got done with a graphing unit. What's the lowest sine ever goes to? Isn't the lowest it goes? I mean, regular sine, not some adjusted sine. -1. The lowest sine ever goes to is -1. How's it going to ever be -4? It isn't. Regular sine can't be -4. No solution. What if I'd have just asked you to find the sine, or the inverse sine, and you thought the answer came out to 3 pi over 2? Nope. Can't have an answer down there. That would be negative. What if you thought the answer came out to 5 pi over 4? Nope. It's in the dead zone. So there's a lot of answers now that just aren't possible. So we gotta watch out for that. It kind of sucks, because if you're taking the test and you feel like there's no answer, it might be because there's no answer, or because you don't know how to do it. You know what I mean? So it's almost like a multiple choice test where they add none of the above. It's like, oh, in case you don't know this, it hurts a lot. It makes it much harder. Because then, otherwise, if you know it's one of those 4 answers, you can kind of like reason through which one must it be. But if they add a none of the above, it's kind of like that. So we have that more often. That's one of the reasons this is hard. Okay, so that one, no solution. If you tried to draw the triangle, I hope you'd eventually realize, wait a minute, the hypotenuse is tiny. You can't have a hypotenuse that's tiny. It doesn't work. All right. This is the kind where they're nested. And the first one's nice. The first one gets a present from Santa Claus. But the second one is naughty. For right now, just focus on the first one. Jack, where do you start this problem? Inside or outside? And on the inside, you rewrite. What do you rewrite it to?
First, what I did is I did tan to the -1 of 4/5.
Okay, that's really not changing the question. You're just like you like that better, so that's fine. Okay, then what?
And then change just to tan of theta equals 4/5.
Nice. Now we're going to draw a triangle. Myung Hai, can you tell me how to draw a triangle for this scenario?
Well, first you exclude the both left quadrants.
Because inverse tangents only allowed on the right side, you're going to exclude those. I like it. Then what?
And then I narrowed it down to the top right first quadrant.
Because why?
All are positive.
Because their tangent's positive there. And tangent would not be positive here. I like it. So now I'm going to draw a triangle. Boom, boom, boom. Tangent, TOA, opposite, adjacent. 4, 5, what? Is it the 4, 5, 6 triangle? Wouldn't you like it if it was that simple? No, you got to do these nasty square roots to figure it out. So 5 squared, 25. 4 squared, 16. Longest side, add them. 30, 40, square root of 41. Put your hand up if you beat me to the square root of 41. Nice work. Okay, now, a lot of kids get stuck right here. So they're like, okay, I got my triangle, so now what? What would you say to do if it was your sister and she's like, okay, I got this far, what do I do? Explain it in easy language.
So I would find the angle. So it's the cosine thing now. So
Yep.
I can find cosine instead of tangent of that, and cosine is
Cosine
over hypotenuse.
adjacent
5 over the square root of 41.
5 over the square root of 41. Raise your hand if you feel like you understood that. Online kids, you getting this? Or have you all fallen asleep? Good. Most of you are not asleep. All right. So, I warned you about this one. Number 2. Seriously, I get how you might just go, nope. Don't know what to do. But let's say that I offered you $1 million to figure out the answer, and you could work as a class to figure it out. Okay, so these are imaginary dollars, by the way. But okay, great. And no cheating apps. How about that? So the sheet. Do you have the sheet pulled up yet, sir? Which thing from the sheet do you think might apply? Everybody think about that. And then let's, without me helping you, let's see if you can work together. I'll try to just guide the conversation for person to person. See if you can figure this out. Mr. S, do you know which one off the sheet would apply? Okay, find the sheet. Look at it. Raise your hand if you feel like you've got the one on the sheet that might apply. Yes?
Maybe tan x equals tan theta equals sine theta over cosine.
Okay, and I know you're saying tangent because of this one, but nope. We don't want that one. I know you must be like, well, you always tell us to start on the inside, but we have to get the big picture first off the sheet. Which of our sheet functions applies here? What do you think, MN? Because it's got sine of something plus something. If you haven't caught this yet, arctans, or tangent to the -1, are angles. Those two things I underlined in red, those are angles. You don't know what the angle is yet because you haven't figured it all out, but those are going to be angles. You got to get that straight in your head. Whenever this is an arc or a sine with a little -1. Inverse trig problems give you angles. So it's really sine of this angle plus that angle. So, Minnesota, MN, can you tell us the actual one that applies?
Sine x plus y equals sine x cosine y plus cosine x sine y.
If I only knew how to find sine of x. Well, which of the two underlined things, here's the underlined things, I'll underline them in blue now. Well, I got blue one and green one. Which of those do you think is x? Say it if you know it. The blue one's going to be the x. The green one's going to be the y, because it's sine of x plus y, right? Okay, so the blue one's going to give you x. This one's going to give you x. Who thinks they know what to do next? What do you think, sir?
Find the triangles and the missing side.
All right, we're making a triangle. Where? For this cosine one,
First quadrant.
I'm feeling like you're probably right, but can you tell me why you ruled out some?
Because it's arc cosine.
So if it's arc cosine, which ones can't it be?
2 and 3.
I think that's 3 and 4, but I think I know what you're talking about.
That's what I meant. That's what
Okay, and then you said the first quadrant, and you were right, but how do I rule out quadrant 2?
well, since
Cosine is positive, it can't be here. Nice. Now, I draw my triangle. Now, what do I put?
adjacent would be 2, hypotenuse would be 3, and then the opposite
I found it to be perfect. Very nice. Now, you might be thinking, but I don't know the angles. And you said that was an angle. And you're right, but I don't really need to know the angle. I need to know the sine of the angle. Hagen, what's the sine of the angle in question? Going up to here. Yep, that's the sine of the angle. The important angle, of course, is always this one. So sine is root 5 over 3. Hey, we got our first little part done. Root 5 over 3. You just got to do that 4 times and add them all up. Seriously? Just to get one problem? Yep. All right. I sense there's somebody that's not with us. I'm not saying who, but get on this. Start doing these problems with us so I don't have to have an uncomfortable conversation with you. All right. Now I got to do cosine of y. Chloe Mack.
Yep.
How do I do this y? The y is the green one, so how do I do a picture for that?
Make a circle.
Do. Now what?
You can rule out is it the second and the third quadrants?
Okay. Because why?
Because it's inverse tan and it
Can't be those two. Okay, good. Now what?
now because it's both of them are positive, so you make your triangle in first quadrant.
All right. So tangent is positive. Or yeah. If I rewrite this, it's really tangent of some angle is positive 4 over 3. And it's okay to have the bigger number on top because this is tangent, and that's opposite and adjacent sides. So 4, 3. And do you know the last side in that? It's the 3, 4, 27 triangle. Come on. 3, 4, you got it. You want to do it the long way, don't you? Okay, so 5. There you go. Yeah, it was 16 and 9, and you add them, and then it's square root of 25, and it's 5. Okay. Tell me what to do now. Cry a little bit.
Which part are we on now?
Okay, we're doing this part right here. So we just got this triangle drawn for y.
Yeah.
This was our y angle. In fact, I'll put a little y in there for you.
Okay.
There's a y right there. So now, what do I do?
You want the cosine of y?
Yes.
So you get adjacent over hypotenuse, which is 3 over 5.
Nice. Now the rest of them are going to flow pretty easy because we already got our triangles drawn. Helena, what do you say about cosine of x?
I think it's 2/3.
You are correct. You put yourself one way, sir. Not just in your lap. I know you got an important conversation. Don't take it back out. Mom will understand that when you tell her later that I got busted by the math teacher. All right. So I got a 2/3, and then what do you think for the last one?
Let's see.
Sine of y.
Sine of y. I said it. Wait, sine of y is a problem.
Sine is opposite over hypotenuse.
Oh, I'm sorry.
It's all right.
4/5.
There you go. 4/5. Automatic built-in common denominators. You get all that and more. 3 root 5 over 15 plus 8 over 15 is 3 root 5 plus 8 all over 15. Whew! That is some serious math. All to just get one question right on a test. Feel like you're in a hard math class? Sometimes. I do hear people say, they come back from AP Calc, and I hear two stories. Some say AP Calc was easier than this class. And other people say that AP Calc was harder than this class. And so I don't know which one you'll be, but I can tell you that this is kind of comparable level to AP Calc. So there's going to be days like this. I honestly think that I've heard this saying before, and I think they're pretty much right, that the calculus of calculus isn't really that hard. It's grinding out the complicated details, and that's exactly what we're doing today. None of this is super hard. It's like drawing triangles, putting sides, finding the third side of a triangle. But there's just so many steps. If you screw up one thing, and you have a 3 root 5 minus 8 over 15. You know, one little mistake in the details, and you lose the points. All right. This is really not on the nice list. It's definitely on the naughty list. Can you tell me which sheet equation we're going to need for this one? What do you say, sir? Double angle. Where do you see a double angle? Maybe in there. That's an angle, isn't it? Didn't I just say a second ago that arc anything is an angle? Cosine of 2 theta. If I just scribble this out and said it's an angle and I called it theta, do you get it would say cosine of 2 theta? Ah. Okay, Hagen, can you tell me the actual formula for that then? Well, there's 3 options, right? Correct. Don't use the one with cosine and sine. Just keep it down to one function, okay? So either of the two. I don't care. All right. Now, can I just go right away? And if you tell me what theta is, I'll know the answer. But do I know theta just like that? No, it takes some work to figure out what theta is. But as soon as I know what theta is, I just am going to take cosine of theta and square it. That's what cosine squared theta means, is you find cosine of theta, and then you square it, and then you times it by 2, and then you subtract 1. Okay, so just, do you get, if I knew what theta was, I could do it. So theta is this. Gracie, how do I do the blue underlined thing?
Well, first you put it into a new form. So cosine theta equals 1/3.
Nice. And does this have any restrictions on it?
It does.
you're right. You're good so far. So what can't it be in?
It can't be in the bottom two.
Good. Now, because it's positive, where does it have to be? Quadrant 1 or 2?
1.
Yeah, because cosine would not be positive here. If I write out my little ASTC thing, it might help. Cosine is only positive on the right side. So, there it is. Jack Sand. I've got my triangle. Tell me what sides to put where.
Adjacent's 1, hypotenuse is 3, and the opposite is
Square root of. Just tell me what you're going to subtract.
9 minus 1.
Yep. Ergo square root of 8. Could I simplify that even further? Yeah, unfortunately.
2 square root 2.
Ooh, fancy. 2 root 2. Okay, so what was the point? I've got a triangle drawn. I don't know the angle. You never will know the angle. You don't really need to know the angle. You need to know cosine of the angle. If I asked you for cosine of the angle, could you tell me that? You get what I'm saying? We're trying to figure out cosine of the angle, and then we'll square it. We don't need to really know the angle. We need to know cosine of the angle. So if I put this as 2 root 2 right here, what's cosine of the angle? And in this case, I didn't even need that third side. Huh. Cosine of the angle is 1/3. 1/3 squared, 1/9. 2 times that, 2/9 minus 1. I skipped a bunch of steps there, so I should probably put them back in there. And 2/9 minus 1 is like 2/9 minus 9/9. Negative 7/9. Whoa. Okay. So, my critical crossroads right here. I know this has been tough stuff. And I feel like you've got the gist of what this is. And the test isn't tomorrow, Saturday. It's not going to be Monday either. So we've got some more time to get this. What I think we should do is have you try a few problems. Remember that there's a key, and understand that you're not supposed to be an expert yet. Okay? So we'll have you try not this one because it's normal circle trig. Doesn't even have an inverse in it. Let's have you try this one. Right, try that one. Crossing off that one. And then there's posted notes that have the answer. Then if I were you, I would jump to the actual homework, which starts here. And I would skip the first two because they go into cotangent, which, by the way, isn't that scary? You just do tangent, but then you flip it. You remember that cotangent is just tangent, but then you take the fraction it equals and you flip it over. So they're not impossible, but you can skip those two. Why don't you do these instead? Try those 3. And while you're working on that, and then you're going and checking the key to make sure if you're doing it right, I'm going to hand back your tests, and then we're going to see if we can get through those. So that's all I have for the lesson for today. You guys need to do some homework on this over the weekend. And I have a feeling I know why I have scores that are so bipolar on our last test. When I'm reading through them and I go 50, 100, 100, 100, 95, 95, 50, 95, 95, 100. You get what I'm saying? Some people aren't doing their homework. It's my theory. Could be wrong. And I know some of you get it in 100, you're not doing your homework either, but you're just a genius, and that's not fair, but that's life. So, those of you that are getting a 50, you can't handle this class without doing your homework. So, there was a few too many F's on this last test. It was a little scary. So, anyway, we'll do some corrections.